Okay, you've been given a list of men's 100-meter long course freestyle world records since they started recording them. What you're going to do and what you need to do right now is figure out how to plot these points and maybe fit a curve to that. The reason why we're doing this exercise now is not only so you can understand the concept of the limit, but also because you're going to need this technology when you do your roller coasters. So if you want to do your roller coasters well, you might want to learn it. Now, I'm going to just plot 2 or 3 points. I'm going to show you how to fit one particular curve to that, and you're going to play around with it. So if you want to plot a point, it's really easy. In the input down here, you just type a parenthesis and you put in a coordinate. In 1922, and I'm just going to use the last 2 digits of the year, you might want to be careful if you get up into the 2000s because you might have to put a 1 in front of it. Think about this is your X value. So 1922, it was 58.6. I press enter. Guess what happens? A point plots out here for me. Let's go on with the next one. 1924 was the next time it was set. It was 57.4. Whoops, 57.4. And that plots us another point. The next time it was set was 10 years later in 1934 at 56.8. They have 3 points. As you can imagine, because this is a world record setting, the time that the record is going to go down, 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 and it's going to continue to go down as more records are set. Now this is going to be a rather flattish curve because we're only talking seconds or milliseconds of beating the record. So if I want to fit a curve to this, it's not necessarily going to be something, that we know right off the top of our heads. It's kind of like a reverse exponential. But GeoGebra has some tools for us to help us fit curves to points. And if you type in the input line, fit, it's going to pop up a whole bunch of different types of things. We could fit a polynomial, but we know our cubics and our quadratics, this kind of curve isn't going to look like one of those. We could do a logistic. It might look something like that. It might look like an exponential. It might look like a growth. But we can also do fit POW. And what fit POW means, if you look at the stuff from GeoGebra, their help, it calculates a regression curve. And maybe that's a good curve for this. I don't know. This is something you'll have to play around with. But here's how I do it. I type in fit POW, and it's telling me I need a list of points. So I type in a list of points, A, and all I have to do is use the names A, B, C with commas between them. I do that, I hit enter, and I get some sort of curve. And up here, it's going to show me the equation that I get when I do that regression curve, 70.02 x to the negative 0.06. Is that the one we want? I don't know. I've only plotted 3 points. You need to do a lot more than that. We could try another one. If I were going to fit a polynomial to this, like a quadratic, I would go to fit poly. I would put in my list of points, A, B, and C. And then what I have to put in there from there would be my degree. So if I were going to try and fit a parabola to this, I would put 2 for my degree, type in enter, what do I get? Now we know our growth line is not going to look like that because it's not going to keep going up because we're setting records, it's going to keep going down. I hope that helps. I want you to use this to think about the limits, the question that you're being asked for this assignment, and also to think about it in terms of when you do roller coaster curves. Talk to you later.